Thanks a lot. So that welcome to the second part of that presentation. As Karin said, it's about reliability and ultra low latency communication. And for that, well, as each dive starts at the beginning, at the top, I will start, let's say, on a, let's call it a little bit shallow level, but nevertheless, some things that I think are highly important to know why we get down to the top. Or to the ground of everything. So one of the things that always come to my mind is when we are talking about ultra low latency is the first misunderstanding between that and real time, because actually real time is something what I think is extremely relative. So to have some examples here, we could have an activation of a brake of a car. You want to have that and reaction comes there at once. So that is what we feel this is real time. But also all the other examples that you see here, even the ordering of a parcel for Christmas. If that parcel arrives before Christmas, then it's still real time. So this means basically real time is meeting a fixed deadline and you're before that deadline, then you're in real time. If you missed that deadline, well, then you missed the real time. So what we typically confuse here is the point, if you take a look at the right side, on the upper left, you see that mission critical real time. This is what we typically have in mind if we talk about real time, but really be aware that there's so much more to it. Have always in mind, real time is just, as I said, meeting a certain event or point in time and being before that. And the time in between, if it's second or hour or millisecond, it doesn't count. So with that in mind, let's go forward to the next topic that I have is reliability. So what is reliability is also something that I think we should have a clear view. So at the end, the goal of reliability is we have a transmitter, we have some information that is transmitted from A to B, and we have a receiver, straightforward, the information comes there. If that way is done in a good way and the information at the end is received, well, then it was a reliable transmission. That also means if we take that postman here, for example, that letter here on the straight way, that's fine. But also, well, he might meet a dog, it barks, and well, he's running away and has a lot of strain. And then he says, okay, got to relax and I have to drink a beer, and goes to a pub. Has some more beers. Well, he says, well, I'll deliver it later, but too many beers. Then he has to relax at the end. And even after a good night's sleep on the next day, he delivers the letter. It's still reliable. It's only you need more time for it. But have in mind, reliability means only at the end, we are transmitting information and the information comes to the receiver in a good way after whatever time. So to bring all this together, we should also have a look at what is affecting reliability. So if we are directly looking at the base station and a mobile user, well, we have our way to transmit. But first thing we have to have in mind is distance, of course. So the further we are away from the base station, well, it becomes unreliable because power is becoming less that we receive. That, of course, will be enhanced the moment, well, if we have some blockage in between, then all this, as you're obvious, or as it is obvious, well, power at the receiver drops. But also, if we have some reflections, that will also affect our reliability, because as you can see on the right side with that waves, there might be a positive or a negative construction or overlay of the waves. So it might happen that you have a good reception, or it might happen that you have none at all. So here we have some effects which we have to live and which we have to cope. And finally, of course, we have always the topic of interference. So if someone is transmitting something on our frequency band, then obviously that will also affect what we have as reliability. So what can we do about it? So first, of course, we can have, let's say, I call it a brute force approach. So obviously we can increase our transmission energy. So instead of using a small hammer, we use a large one, more energy. We have definitely our limits there, but it's an easy, straightforward approach. So, well, let's have more signal power, more bandwidth. Let's shape the antenna pattern. But in the end, this does not change the fact we are just increasing the energy. Or on the other side, we could be a little bit more smart and say, well, we harvest the energy in a more clever way. So at the end, we use more or a different modulation. We use a different code. We could also, what I don't have here, we could have multiple antennas, but in the end, it's also, we are just using means to extract more energy for the information that we are receiving and try to reconstruct by that. But of course, this is brute force, and well, there are smarter ways to do it. And the smarter approach is also, well, most of you will know, it's if we don't manage to transmit on the first try, well, we have more than one try. So we can use retransmission. And this type of increasing the reliability, we can do just simple, well, we just retransmit many times or a fixed number of times, then this is a good way to go, but well, wasting our resources. We can also have some intelligent retransmission. So depending on what was already transmitted, we get some information back. So this is, for example, if we are talking about HARC, then we are only transmitting what was not received in a correct way. Or depending on what was not received and let's say on the importance of what needs to be transmitted. Maybe we drop some of the information that is not so important, and then we are just transmitting what is urgently needed, and that with all the resources that we have. So there we can adapt our retransmission depending on what we have. The other way is if we have more than just, or there's typical always more than just one route. You do not only have transmitter, receiver, but you could use different transmitters, and you're using the transmitter that has the best chance to transmit the information to the receiver, for example. And in other ways, maybe you have a relay that you can transmit your information to, and from that relay you can reach the receiver. And finally, the option is also you're not alone, typically at least. So it is possible to not only that one transmitter transmits and finds out, well, the transmission is not working in any way, but you can combine different transmitters and so they can help each other. For example, they are adding their power to have or to reach the receiver in the end. And there are many methods to really achieve this, but this just for an instant for you to have an idea what are methods we could use to achieve more reliability. And with that, let's say from the general topics, let's go further into the real realization then inside 5G. And with that, I would hand over to Thomas.